In today's short video, we're going to look at displacement and immersion problems. So displacement and immersion problem is where we have one shape and it is put into a bigger shape, and due to that being put in, it's covered in water, the level of water will increase. So before we look at displacement and immersion problems, it's a tough question because there's a lot to it. But everything that is in this question is pretty much previous information you would have seen either in primary school, first year, and some information we would have seen this year in second year. So the first thing you need to know is the volume of the cube, the cuboid, the sphere, and the cylinder. The formula for the sphere and the cylinder are in your log tables. I will send out an electronic copy of the log tables for those who don't have them in time for the summer exam. Sometimes we've seen problems where you've been asked to find an unknown dimension, and when you're given, you let it equal the volume, and you solve like an equation. If it's the radius, it could be an r squared or an r cubed. To inverse squared, we use the square root. To inverse r cubed, we would use the cubed root. And then the new piece of information, okay, that you would not have seen before, okay, it's quite easy, it's quite basic, is the volume of what's immersed. So in the example over here, the volume of the cylinder will equal the same as the volume of the displacement. So let's just draw that. WH, just that little bit there should equal the same as the volume. I'm going to, if you want to open your textbooks on page 402, we're going to look at question 12. You can pause the video while you open it. Okay, you don't need the book. So, the question we're going to look at is, if I had a sphere of diameter 6 centimeters and it is immersed in a bigger cylinder of diameter 16 centimeters, how high would the volume of water be displaced? So, using the 4 pieces of information we've looked at earlier on, we're going to go through it step by step. So, step 1. Okay, we're going to find volume of a sphere. Okay. So the volume of the sphere is V equals 4/3 pi r cubed. Okay, we look at it, we look at what we need to find. Okay, we're given already this diameter 6, so the radius is going to equal 3. With these questions, we can leave it in terms of pi. So we don't need to sub in a 3.14 or 22/7 for pi. I will show you later on in the question why we don't. Okay, so when we sub it in 4/3, 3 cubed, no harm putting that in brackets, by pi, that should equal 288 pi. That will be our volume of the sphere. Okay, so after we've found that, we know that the volume of the sphere equals the volume of the displaced. Okay, so we have to look at the object that is displaced in this case. It is a cylinder. We remember that our volume of a cylinder formula is pi r squared h. Okay, so as we said earlier on, we're going to leave pi as pi. The radius of this cylinder is 16 over 2. So your radius is 8. So you have 8 squared h by pi. And as we said earlier on, that equals the volume of our sphere. We're looking earlier on, we bring our 288 pi. What I would do, 8 squared becomes 64. Because our variable, our unknown, is on the right hand side, just to make your things a little bit easier, we'll put it to the left hand side. So we have 64 pi by h equals 288 pi. At this case, we have a pi on both sides. So as I said, if you did give a pi a value, it wouldn't matter. We leave in terms of pi because we could simply just cancel our 2 pi's. We're left with 64h equals 288. That's 64 multiplied by h. The inverse, the opposite of multiplication is division. So we do 288 divided by 64. Okay. And h will equal 4.5. We go back to the question. We see that our units were centimeters. So the water displaced would be 4.5 centimeters, and that would be our final solution.